Hello, my name is Larry Krzyzewski, and this is my CISS100 final project, where I install an Octopi instance of Octoprint onto a Raspberry Pi. So Octopi is a Raspbian-based SD card image for the Raspberry Pi that gives you a MJPEG live streamer from the Raspberry Pi camera or from a webcam. It includes the Cura engine 1504, which in my case I don't actually use the embedded Cura engine. I will actually use Cura the software. And it also allows you to remotely operate your 3D printer. So we're going to go over the installation. I'm going to go over a brief overview of the interface, and then I will show you a time lapse of a print that worked. There is a few failed prints in this, but that is not the fault of the Octopi or the Raspberry Pi. It is the fault of me purchasing cheap filament and the filament not extruding properly. If you're unfamiliar with 3D printers, I will try to touch on a little bit of that, but it's kind of out of the scope of this project. So let's move on. So the first thing you do is you download Octopi. Just like any other software, it'll come up with the little box to download. After I downloaded it, I ran the WinMD5 free and confirmed the MD5 checksum value. And as you see on screen, the original and the current match, so it was valid. Now, in order to take with a file that you download, which is a disk image, and put it onto a micro SD card for the Raspberry Pi, you have to use software to do that. I chose Etcher. Etcher is a very simple, lightweight program that allows you to do this, and this is their home screen at etcher.io. So first you select your image, then you select the drive in which it's going to be burned to, and then you flash it. So as you can see, I've now selected all of my my file as well as my device, and I hit flash. And I'm going in the wrong direction. There we go. So sorry about that. So now we have it flashing, and it'll tell you how much longer you have, and when it completes it'll let you know. Okay, so you then take that SD card and you put it into your Raspberry Pi and you boot it up. Now, I'm not going to show that for two reasons. One is that I don't have screen capture on the Raspberry Pi because it's not actually running the Raspbian desktop. It is a CLI only, and the setup is extremely brief and basically involves running the sudo apt-get update to update all the files, and then you run a ifconfig to get your IP address. And now on screen now you see this is the opening screen of the Octoprint or Octopi instance, and if you look in the address bar, you'll see that my Raspberry Pi is living at 192.168.0.8. Now this is the local address on my network at my house, so it's not really accessible from outside of that. There is a way to do that, I just have chosen not to do that. So onto Octoprint itself. So this is Octoprint's first screen, as I said, and you set up your access control. So I have set a username and password for my Octoprint, and it gives you the option to enable or disable access control. I would highly recommend anybody doing this to keep access control, because you don't want the possibility of somebody being able to remotely turn on a device that can get to up to almost 300 degrees Celsius in your house. Okay, moving on. Alright, so now we're going to set up a slicing profile. Now, as I said, I don't use the Cura engine that's embedded in the Raspberry Pi. And for those unfamiliar with what I'm talking about, A slicing engine is where you take your solid file, typically an STL file, surface tessellation language, and you're dropping it to the slicer that looks at it and basically slices it into many different layers at the layer height you've determined, and then figures out how to deposit material in order to make that part. So with Octopi, you can actually just take a solid model file, like an STL, and drop it into the Octoprint instance, and it will slice and print all in the same Raspberry Pi. Now, my workflow already includes going to Cura for my particular printer, and so I don't need to do this step, but you can import a profile. I just skipped it. Now, my default printer profile, this has a few tabs, so when you're setting it up, you want to make sure you hit all 4 across the top. My printer is a Creality Hicktop CR10S. It's a large, very affordable printer, and of all the printers I've used, it is one of the better ones. And you'll see that towards the end of the video. So first I fill out the name. The identifier can remain as default, and the model is, as I have here, a Hicktop Creality CR10S. Okay, now my form factor is a Cartesian machine. Cartesian means that it has a X, Y, and Z axes. So the form factor rectangular is selected, and the origin is in the lower left of the build plate. I have a heated bed, and my print volume is 300 by 300 by 400 millimeters. If you're unfamiliar with what a circular form factor is, I recommend looking up a Delta 3D printer that uses a alpha, a beta, and a gamma axes, and operates in a fundamentally different way. They are really cool, but maybe if I set up my other printer with Octoprint, I will detail that as well. The next option down is a custom bounding box. Now, I don't need a custom bounding box because I only have one extruder, but you can actually set a custom bounding box to make sure that your prints stay within a certain space so that both extruders, if you have a side-by-side extruder setup, can access the print. Going on to the next. Okay, so now we have our axes. Now I leave these as the default because 6,000 millimeters per minute, which is 6 meters per minute, sounds extremely fast, and it is. But these are going to be dictated by the onboard firmware of my printer. So these are by default set higher than what my printer will do, and my printer will regulate itself. So the 6,000 and 6,000 on the X and Y axes is fine. The 200 millimeters per minute on the Z axis is good. Now the X and Y on my printer move with belting. So a belt is a direct drive, but very quick because you're able to drive it fairly rapidly. The Z axis involves 2 lead screws, and the lead screws have a very small pitch, so that as you go for the same speed on the Y axis, that'll give you 6,000 millimeters per minute. You're going to be closer to that 200 millimeters per minute of actual Z travel. And then the E stands for extruder, and that is 300 millimeters per minute, and that's actually what pushes the filament through the machine. Finally, we have hot end. Now the hot end is the part of the machine that actually heats up the filament and deposits it. So the nozzle, which is the end of the hot end, and the extruder has a orifice of 0.4 millimeters. So it's important that you set that for deposition rates. And then the number of extruders, as I said, is 1. So finally, we're all done with the setup wizard, and you can just hit finish, and you'll be prompted with this, please reload. So we reload it, and we come to this Octoprint screen. So this is the home screen for the Octoprint. I'm going to go over it in a second, but I do want you to notice that it says there's an update available. So we hit the update now button, and it's going to ask if we're sure. I highly recommend that you constantly update this. This is a open source project, but it is maintained fairly well, and you'll see quite routine updates. And they may be adding features, they may be increasing stability, or they may be doing like a hot fix to a bug that they've identified based on dependency software. So we hit update, it runs more, says it's complete, it'll restart, and then you come back. Now, as you come back, this is what popped up, and it's the connectivity check. So this is how you set it up so that you can go outside of your home network and print to outside. Like I said, I haven't done it because I don't wish to do that, but perhaps in the future. And then a plugin blacklist, and the plugin blacklist, and I'll talk more about plugins in a moment. But the plugin blacklist, basically, as it sounds, limits certain third-party plugins that have been known to cause issues. So I would highly recommend we enable the plugin blacklist processing. All right. So now we're at the home screen of Octoprint, and we see the serial port selected in the drop-down menu up to the upper left. And you see where it says dev tiny USB 0. So this is a Linux operating system. So if you were on, or if the computer running Octoprint was a Windows computer, you would probably see a COM4, COM3, COM6, something like that. Linux-based computers access this through the dev.tty USB 0, or you may see AMC. So we just go and we select the USB port that the printer is connected to. I have my printer profile there. You can see the CR10S, and we hit connect. Now, if you see, it says state is operational, and over to the right, you'll actually see where it'll, in that graph, well, it's not really a graph yet, but this is right after it had just started, so it hadn't actually loaded all the data. And you can see the actual temperature at 17.1. Oops, sorry. 17.1 and 15.5 degrees Celsius. This actually provides live feedback of all the temperature and temperature monitoring, as well as allows me to move the machine, turn it on, drop a file into print, and to set up a bunch of things. So I decided, hey, I'm going to print something fancy. So we're in CISS100. So I said, you know what, I'm going to make a model real quick. So I went over to Inkscape, and Inkscape is a open source vector art graphics program. Again, free to use, and very similar to Adobe Illustrator. It's a little different, maybe not as featured, but quite popular. If you have any interest in doing vector art, I highly recommend you check it out. So I make this simple thing. I use Trajan Pro, which is my favorite font, and I make a simple vector art design. I then convert that to paths, and then I drop it into Fusion 360. Now, Fusion 360 is a 3D modeling program that also allows for computer-aided manufacturing, CAM software, which I use in my CNC mills, as well as exporting for 3D printing. It is free for student use or for anybody who earns less than $100,000 a year with it. If you have any interest in 3D modeling, I recommend you go check this out. This is not open source. There are open source options available, but if you want a professional tool without having to pay for it, I recommend you check this out. So as you can see, my Trajan Pro CISS100 was brought in. I made a quick body out of it and extruded it out. And now I've selected the make command. And if you can see, it's in the toolbar in the center of the screen. It's highlighted in blue. And when I select make, I select 3D print. And now I make the selection. So I select the model. My refinement is to high. But then under output, I say send to 3D print utility. Now my 3D print utility I have selected as custom, and the application is Cura. This is something you set up once, and then in the future it will go there for you. So you hit OK, and it imports it into Cura. Now I know it looks like a block. I actually didn't realize that when I saved all of it, I forgot to save where I actually placed the model laying on it on the flat, and the model did come in properly. Now this is Cura. Cura is the slicing software that I had briefly touched on, where you take in a model and it will slice a model into thin layers and will determine where it needs to deposit the material. It'll then generate the G code, and the G code is a simple alphanumeric representation, basically a scripting language that CNC machines and 3D printers work on, where certain commands have certain actions associated with them. So it could be to set a speed, to make a movement, to move an extruder, to move in a circular pattern, and the onboard controller of the 3D printer or CNC mill will interpret that and make those movements. So it allows for command files that are very small relative to the amount of data that they carry. It also allows for smooth movements to be made without having to move in linear motion in small lines on each thing. But that is a whole other topic. So moving on. If you look over to the right, you'll see layer height, which is 0.2 millimeters. That's 200 micron layer height. That's an average quality. It says draft quality listed, but that's an average quality for most prints that you would do. If you were really outputting something that, like maybe a small figurine or a model for a tabletop game, or just a part that needed to be really high precision, you could go down to 0.1, which is the limit of my printer. There are printers that'll go down further than that to 0.06 millimeters, which is 60 micron layers, and those come out pretty much smooth to visibly smooth. Now, I set some other things, and for those of you unfamiliar with 3D printing, typically you'll have perimeters which print on the outside of the print and form the outside walls, and then you'll have infill. And infill can vary by percentage, so even though you would assume that a solid part would actually be as strong as possible, filling up a 3D print does not necessarily make it any stronger. So infill density I have set at 25%. It wasn't really a necessity for strong prints. In my previous degree, we actually conducted an experiment where we took 3D prints of various infill percentages and tested them against each other, and found that above 50%, typically the strength does not change, because at that point the amount of material is no longer exceeding the layer adhesion between layers on typical FDM printers. And when I say FDM printers, 3D printers that deposit material are called fused deposition material machines. So FDM printers typically don't benefit from infill percentages above 50%, but that also depends on your application. Alright, so first in Cura, I want to connect it to Octoprint. So I now have a workflow that I've gone from Fusion 360, and I've linked that to Cura. But now I want to link Cura to Octoprint. And this is the plugin page for Cura, and if you look about 3/4 of the way down, it'll say Octoprint connection, and it's the one that I already have installed. So it enables the networked printing and monitor with Octoprint. So I went ahead and downloaded that, and then you have this where you can set it up, and it says an API key. Now the API key you generate from Octoprint. You just go to the to your instance of Octoprint, and it just tells you what it is, and you put in the API key, and that allows you to link your Cura to your instance of Octopi. So I do that, and now you have where it's set up. So it says Creality CR10. Okay, this is the printer profile that comes with Cura for my printer. My printer is the CR10S, but the update was not something that really affected the firmware settings. But anyway, so you can select connect to Octoprint, and once you do that, you get this monitor capability. And if you look, this would be a live feed of my CR10S, which is the printer on the screen, and with some basic controls. Now you can see the build plate on this one is preheating. This is after I had sent it the first print. Once I had sliced it to my liking, I sent it to print, and this is it basically preparing for that print. Now moving back over to Octoprint, and this is on a web browser again, you can see that the set point has jumped up for the bed, which is in blue, and the hot end, which is in red. The target temperatures are 60 degrees and 200 degrees respectively, and you can see how over time it's coming back up to that. Now at this point I've been turning it on, turning it off, trying to get this thing to print, and this is where the failed print comes in. So the first failed print was due to my filament not adhering to the bed properly. I re-leveled my bed several times and probably went slightly crazy, but after a while it just wouldn't work, and upon not giving up but being frustrated for a few days, I opted to go to a model that I knew printed. I thought it was more important to get a model to show it printing than it was to have a particular model. So here it is. This is a Duplo compatible boat that I printed for my son, and I have several copies of this boat running around my house now. So I figured I'll print another one. So as you can see, right, the boat is placed in the slicer. The slicer has determined it'll be 3 hours and 36 minutes. And it tells me it is 43 grams worth of material, and the only option is in euros, but that is 73 cents based on the price of filament. So not a terribly expensive project. So if you look on the bottom right, it says print with Octoprint, and that allows me to send it directly to Octoprint. And now this is me monitoring it from the web page, and monitoring it going over that whole period of time. So thank you for watching this portion. Stick around for the end of the video. I will put in the time lapse of that boat project printing, and you can see it. Now it prints properly, but it did under extrude, and it is not until several days later that I've corrected that problem with an alternate build surface. Thank you, and I hope you enjoy.